Here are the notes for today. We're doing exponential growth and decay, and we're going to do some word problems, some application problems. So this is still section 8.1. Exponential functions. Day 2. So we'll do a word problem first. So let's suppose, and I don't know if this is true, this is just what your book said, that the population of the U.S. in 1984 was approximately 260 million. And then your book said that at that time, or at some point in time, that the population was growing, and populations grow. So, populations of people grow, and they've been growing for a long time. So it's growing at a rate of 0.7% per year. First thing we're going to do is make an exponential function that describes this situation. Okay, so we'll use our exponential function format y equals a times b to the x. When we're doing application problems, a is not just the y-intercept. A is usually the initial value. And b is either the growth or decay factor. So this one is growing, so I'm going to call it the growth factor. So the initial value is the value in 1984 of the population, which is 260 million. And we won't write out all the zeros. We'll just call the units millions of people and just call it 260. And my growth factor, if I have exponential growth, that's going to be my percentage increase added to 1. If I have exponential decay, that's going to be 1 minus my percentage decrease. So, since this is growth, we'll say it's 1 plus 0.7%. In a decimal is 0.007. Okay? Yeah? Okay with that so far. All right. So my equation is going to be y equals 260 times 1.007 to the x power. Now, since this is an exponential function, a word problem, we're probably going to want to solve some problem now. So let's see if we can find the predicted population. In the year 2020. So I'll use this function, y equals 260 times 1.007 to the x power. And remember, x, when we were talking about cars, was years. Years you've owned the cars. This time x is going to be years since 1994. So I want 2020, so I'll take 2020 and I'll subtract 1994 and get 26. So my x needs to be 26. You go back 84. Sorry. 1984. Making that 36. There we go. Okay. Now I'll just use my equation. Y equals 260 times 1.007 to the 36th power. And you would never do this without your calculator. I guess you could use a slide rule if you knew how to do that. Or if you had a tremendous amount of time, I guess you could do this without your calculator. But taking 1.007 to the 36th power is not going to be a lot of fun unless you know some shortcuts. Alright, so that happens to be 334.22. So that means the population in 2020 is predicted to be 334.22 million. Okay. So, and you'll have some other word problems to do like this. Some of them will be decay. So if we are doing exponential decay, your b isn't 1 plus 0.007, it's 1 minus 0.007. So I'll put this in red writing. Growth is 1 plus the percentage. Decay is 1 minus the percentage. And you put that percent in a decimal. Okay, so now we'll move on to non-word problems that are a little more difficult, and that is finding an exponential function that if you're given 2 points. Excuse me. So we are going to start off with the 2 points, 2, 4 and 4, 20. So if I think of what we're looking at here, we got 2, 4, 4, 20. You know, we're looking at an increasing exponential function. Okay. I'm going to use my y equals a times b to the x format, and I'm going to substitute in the x and the y. I'm going to do it twice, once for each point, and then I'll have an equation that I can solve for a and b. So, and this one is kind of a little tricky one. It's kind of a, I like a little shortcut method. So, I like to substitute in the point with the bigger x first. So I'm going to substitute the 4, 20 into this equation. So I get 20 equals a times b to the 4th power. And then I'll substitute the 2, 4. And I get 4 is a times b to the 2nd power. Now here's where I do something a little bit tricky. I make those two equations and I turn them into a ratio. And I get 20 divided by 4 is 5.